Hello everybody, welcome into another lesson. So today we are going to continue on with matrices and we're going to talk about matrix multiplication. When we think about matrix multiplication, it's not the same as multiplying conventional numbers. Now you have a matrix A with dimensions m by n and you have a matrix B with dimensions n by p. The only way you can multiply two matrices is if and only if the number of columns in the first matrix equals the number of rows in the second matrix, thus the m times n and then the n times p. If those match, then you can multiply the matrices and you'll end up getting a matrix that is m by p, which would be the number of rows in the first column times the number of rows in the first matrix times the number of columns in the second matrix. That would be the dimensions of AB. It's also important to note that matrix multiplication, unlike regular multiplication, is not commutative. So in other words, matrix AB does not equal matrix BA. For one, you may be able to do AB, but it may not be possible to do BA, or even if it is possible to do BA, you're going to get a completely different result than matrix AB. So let's demonstrate here with some examples. Alright, so here's what we're going to do. We're going to do, here's the first matrix. You have negative 1/6, you have 1/2, and then you have negative 1/3. You have that matrix times the matrix of 12, 0, and negative 12. So is it going to be possible to multiply these matrices? First thing I'm going to suggest is you find the dimensions of each matrix. So the first matrix A, we'll call the first matrix A, has dimensions of 1 row by 3 columns. So this is a 1 by 3 matrix. The second matrix we'll call B has 3 rows by 1 column. Well, the number of columns in the first matrix matches the number of rows in the second matrix. So yes, it is possible to multiply these. It's completely possible. So how we're going to denote this is you'll take matrix A times B, which would be denoted A times B. Now, how are we going to do this? Your result's going to be a 1 by 1 matrix. It's going to be the number of rows in the first matrix times the number of columns in the second matrix for your dimensions. You'll get a 1 by 1 matrix. So what you're going to do is you take the first number in the first row, multiply it by the first number in the first column. So that's going to be equal to negative 1/6 times the positive 12, plus you'll take the second number in the first row and multiply it by the second number in the first column. So that'd be 1/2 times 0. And then you would end up taking the third number in the first row, which would be negative 1/3. You would multiply that times the third number in the first column, which would be negative 12. So then, what's negative 1/6 times 12? Well, that's going to be negative 2, plus 1/2 times 0, which is 0, plus negative 1/3 times negative 12, that would be positive 4, which would literally give you a 1 by 1 matrix with just the number 2 in it. So matrix AB is a 1 by 1 matrix with literally just the number 2 in it. That's all it is. Now, the next question is, what about B times A? Can we do B times A? Is it even possible? Well, let's find out if it's going to be possible. B times A. B is a 3 by 1, A is a 1 by 3. While the number of columns in the first matrix match the number of rows in the second, so yes, it's possible, but you'll get a 3 by 3 matrix this time. So already you got an important difference. You have a 3 by 1 times a 1 by 3, that's going to yield a 3 by 3 matrix. So what you're going to do now is you're going to take the first number in the first column here, or in the first row, you're going to multiply it by the first number in the first row here, 12 times negative 1/6. And then that's it for that row. Well, no, it's not. But yeah, that's not it. Plus, you'll take 12. No, you won't take plus. I'm sorry. You'll end up taking the first number in the first row, multiplying it by the first number in the second column, which would be 12 times 1/2. And then you'll end up taking the third number in the first column. Oh, no, I'm sorry. You'll take the first number in the first row, multiply it by the third number in the third row, which would be 12 times negative 1/3. All right, so there's part of your entries right there. Now you're going to take the first number in the second number in the column, which would be 0, times the first number in the row, which would be negative 1/6. And then separately, you'll have 0 times 1/2. And then separately, you'll have 0 times negative 1/3. And then lastly, you'll have negative 12 times negative 1/6. And then you'll have negative 12 times 1/2. And then you'll have negative 12 times negative 1/3. Which would end up producing a matrix of negative 2, 6, negative 4, 0, 0, 0. The whole middle row is zeros. And then negative 12 times negative 1/6 is positive 2. Negative 12 times 1/2 is negative 6. Negative 6. And then negative 12 times negative 1/3 is positive 4. So you get a 3 by 3 matrix with entries negative 2, 6, negative 4, 0, 0, 0, 2, negative 6, and 4. So this is why matrix multiplication is not commutative. It is associative. If you can multiply 3 or more matrices, you can use the associative property and move the parentheses around, but it's not commutative at all. Because as you see in AB, you got a 1 by 1 matrix with just 2. And then for B times A, you got a 3 by 3 matrix with all these numbers here. So that proves matrix multiplication is not commutative. All right. What about, let's see here. You have matrix A is equal to 1, negative 4, 3, negative 2. Then you got matrix B, which is equal to 4, -1, 0, and -3. We need to determine if AB is even possible. Is AB possible? Well, let's go for the dimensions of matrix A. That's clearly a 2 by 2. How about matrix B? Also a 2 by 2 matrix. The number of columns in the first matrix matches the number of rows in the second, so yes, this is possible. Your resulting matrix should also be a 2 by 2 matrix. So now we're going to take matrix A times matrix B, which is going to be, I'm going to rewrite the matrix to make our lives easier. 1, -4, 3, -2, all that times the matrix 4, -1, 0, -3. All right? So when we do that, you'll end up getting, what you're going to do is take all the numbers in the first row. So I'll take that 1, multiply it by 4. So take 1 times 4, plus I'll take that second number in the first row of -4 times the second number in the first column. So you're actually going to be taking all the numbers in their respective, in the first row, multiply them by the numbers in the first column. It goes row times column. I know that's a little weird, but that's how it's done. And then you could still stick with the first row for your second number. You'll take that first number in your first row times the first number in your second column. So you'd end up with 1 times -1 plus -4, your second number in the first row, times the second number in your second column. -4 times -3, which would then give you, you're now going to do the first number in the second row times the first number in the first column. So that would be 3 times 4 plus that second number in the second row of -2 times the second number in the second column of 0. And then you'll end up taking your second number, your first number in the second row times the first number in the second column. That'd be 3 times -1. Plus, you'll take that -2, the second number in the second row, times the second number in the second column, which would be -3. Now we'll just simplify all this here. You'll end up getting, of course, 4 plus 0. And then 1 times -1 is -1 plus -4 times -3. That'd be plus 12. And then 3 times 4 is 12, plus -2 times 0 is 0. And 3 times -1 is -3. -2 times -3 is positive 6. So you should get the matrix 4, 11, 12, and 3 in the end. That'll be your matrix AB. A times B is yet another 2 by 2 matrix. It's a square matrix with entries 4, 11, 12, and 3. That's exactly what you should get. All right, now, can we do B times A? That's a bigger question. We definitely can because, again, they're both 2 by 2s. If they're square matrices with the same dimensions, you can multiply in reverse also. You totally can. As long as they have, if they're square matrices with the same dimensions, that's a shortcut for you. You absolutely can. So this time, let's figure out B times A, or BA, which should also yield a 2 by 2 matrix. But you should get a completely different result. We're going to take 4 -1, 0, -3, all that times matrix A, which would be 1, -4, 3, -2, all right? Now, to do this, you're going to take the first number in the first row, which is 4, multiply it by the first number in the first column, which is 1, plus the second number in the first row, which is -1, times the second number in the first column, which is 3. That ends the first row and first column. Now skip over. For the second entry, you're going to take the first number in the first row times the first number in the second column. So you would take 4 times -4, plus you'll take your second number in the first row of -1 times the second number in the second column of -2. And then once you've done that, you'll move on to the second row of the first matrix. You'll take that first number in the second row of 0 times the first number of the first column of the second matrix of 1, plus now you'll take the second number in the second row of -3 times the second number in the first column of +3, and then skip over. Now you'll take the first number in the second row of 0 times the first number of the second column of -4, plus you'll take the second number of the second row, -3, times the second number of the second column, -2, which would turn into 4 minus 3. Then you'd have -16 plus 2. Then you would have 0 minus 9. Then you would have 0 plus 6, which would give you yet another 2 by 2 matrix, but you got different entries. You have 1, -14, -9, and +6. So if you want to stop the video and compare the answers to matrix AB to this matrix BA, you'll see you got completely different numbers. You have 1, -14, -9, and 6. All right, so what's next? We have another setup here. It's similar. Matrix A has the entries -6, -2, 0, 3. Matrix B has the entries -1, 4, -5, and 3. So we're going to ask, is it going to be possible to do A times B? Do matrix A times B? Is that possible? Well, let's look at the dimensions of both matrices. Both are clearly 2 by 2 matrices. So yes, these both meet the criteria for matrix multiplication. We can definitely do it. So let me rewrite these matrices. AB would be -6 times -6, -2, 0, 3, times the matrix -1, 4, -5, 3. Okay. So again, when doing matrix multiplication because we should also get a 2 by 2 matrix for AB. You're going to take the first number in the first row, which would be -6, multiply that times the first number in the first column, which would be -1, plus you'll take the second number in the first row of -2 times the second number in the first column of -5, and that'll be it for your first number. Now to get your second number, take the first number in the first row, which would be negative 6, times the first number in your second column, which would be 4, plus take the second number in the first row, which would be negative 2, times the second number in your second column, which would be 3. Now, to get the next row, you're going to take the first number in the second row, which would be 0, times the first number in your first column, which would be negative 1, plus you'll take that second number in your second row of 3 times the second number in your first column of negative 5. That's it for this third number. Now to get the final number, take the second number in your first row, take the first number in your second row, which would be 0, times the first number in the second column, which would be 4, plus you'll take that second number in the second row of 3, times the second number in the second column of 3, which this will simplify into 6 plus 10 for the first number. Second number would be negative 24 minus 6. And then the third number would be 0 minus 15. Fourth number would be 12, it'd be 0. 0 times 4 is 0. Plus 9. So you would end up getting the matrix AB having a value of 16, negative 30, negative 15, and positive 9. That's what matrix AB would equal. It would be 16, negative 30, negative 15, and 9. That would be your 2 by 2 matrix. Now, we're also going to ask, can we do B times A? Is B times A possible? Well, let's see here. Let's look at B times A very carefully. B is a 2 by 2. A is also a 2 by 2. Yeah, it's definitely possible. You should also get a 2 by 2 matrix for your result, but you're definitely going to have different numbers. So we'll take matrix B, which is negative 1, 4, negative 5, 3, times your matrix A, which would be negative 6, negative 2, 0, 3. All right. So again, to multiply, to get your entries for the matrix, you're going to take to get your first number, take the first number in the first row, which would be negative 1, times the first number in your first column, which would be negative 6, plus you'll take the second number in your first row of 4, times the second number in your first column of 0. That's it for your first number. Your second number, you're going to take the first number in the first row of negative 1 times the first number in the second column of negative 2, plus you'll take the second number in your first row of 4 times the second number in the second column of 3. Now to get your third number, you'll take the second number, you'll take the first number in the second row of negative 5. You'll multiply that by the first number in the first column of negative 6. Plus you'll take your second number in the second row of 3. Multiply that by the second number in the first column of 0. And then last but not least, to get your fourth number, you'll take that first number in the second row of negative 5. Multiply that by the first number in the second column of negative 2, plus you'll take the second number in the second row of 3 times the second number in the second column of 3, which will give you a completely different matrix here. You'll end up getting negative 1 times negative 6 as positive 6, plus 4 times 0 is 0. Negative 1 times negative 2 is positive 2, plus 4 times 3 is 12. Then negative 5 times negative 6 is 30, plus 3 times 0 is 0. And then negative 5 times negative 2 is positive 10, rather. Plus 3 times 3 would be 9. Giving you that matrix B times A would be 6, 14, 30, and 19. You get all positive numbers in this case. So matrix BA would be 6, 14, 30, and 19. So this should be going to show you that this is not, that matrix multiplication is not commutative. All right. That is a 3 by 2. All right, how about, let's see, so 3 by 2, 2 by 2. Let's do this one here. Let's say we have negative 1, negative 0.5, 1.25. This will be matrix A, by the way. Well, let's set the stage for that. Then you'll have 1, negative 1.5, negative 0.25. So there's the entries for matrix A. Now what about matrix B? What are the entries for that? You just get 1.2, 0.2, and 0. So we need to ask ourselves first, is matrix A times B possible? Is it even possible? Well, what are the dimensions of matrix A? You have 2 rows by 3 columns, so this is a 2 by 3 matrix, right? Now, what are the dimensions of matrix B? This is a 3 by 1. You have a 3 by 1 matrix. So yes, it's possible because the number of columns in the first matrix equals the number of rows in the second. So that means you should get a 2 by 1 matrix for AB. That should be your product, would be a 2 by 1 matrix. So let's go ahead and figure out matrix AB. To get our numbers here, you're going to take the first number in the first row of negative 1 times the first number in the first column of 1.2, plus you'll take the second number in the first row of negative 0.5 times the second number in the first column of 0.2, plus you'll take that third number in the first row of 1.25 times the third number in the first column of 0. And that's all you can do for the first number. Now to get the second number, you'll take the first number in the second row of 1 times the first number in that column of 1.2, plus you'll end up taking that second number in the second row of negative 1.5 times the second number in the column of 0.2, plus you'll end up taking that third number in the second row of negative 0.25 times the third number in the column of 0. And let's simplify this here. Negative 1 times 1.2 is negative 1.2. Now, what is negative 0.5 times negative 0.2? That should be actually negative 0.1, so that'd be minus 0.1. And then you would have 1.25 times 0, that's just 0. Now 1 times 1.2 is just that, 1.2. Negative 1.5 times 0.2, that should be minus 0.3. And then negative 0.25 times 0, well, that'd be plus 0. Which should end up giving you a matrix of negative 1.3. And then you'll end up having 0.9. And as you see, this is a 2 by 1 matrix. So yes, you get a 2 by 1 matrix with the results negative 1.3 and 0.9. So there is the matrix AB. Now you know what I'm going to do next. We're going to flip it the other way. Is B times A possible? Well, B times A, let's see, B is a 3 by 1 matrix, right? A is a 2 by 3 matrix. Well, the number of columns in the first matrix do not match the number of rows in the second matrix, so B times A is not even possible in this case, because you don't meet the criteria to be able to multiply them. So that's why the order of multiplying matrices does matter. And it's not commutative. All right, let's do one more of this. Let's see. I have matrix A here, which is going to be equal to 6, negative 2, 1, 4, 0, 5. Matrix B is going to be equal to, C, negative 4, negative 2, 5, 4, negative 6, and negative 1. So is it even going to be possible to do A times B, matrix AB? Is that even possible to get? Well, let's look at the dimensions of each. Matrix A, you have 3 rows by 2 columns. This is a 3 by 2. Now, what about matrix B? You have 2 rows by 3 columns. So actually, yes, this is possible to do because you have the same number of columns in the first matrix as you do the number of rows in the second matrix, which means you should get a 3 by 3 matrix for your product with AB. That'll turn it into a 3 by 3 matrix. So let's go ahead and get each of these numbers. So what you have to do now, you're going to start with the first row. You think about it. You're going to get the 3 numbers in the first row. You're going to stick with your first row through and through. So if you take, what you're going to do first, take the first number in the first row, which is 6, times the first number in the first column, which is negative 4, plus you'll take the second number in the first row, which would be negative 2, times the second number in the first column of 4. And that's all you can do for your first number. Now, stick with your first row, take the first number in the first row of 6, times the first number of the second row of negative 2, plus take your second number in the first row of negative 2, times the second number of the second column, which would be negative 6. You know what? Hold on. This is going to be a big one. Hold on a second. Let me rewrite this here. I'm sorry, guys, but I'd rather get it right. So again, stick with your first row to obtain all the numbers in the first row. You're going to take that first number of 6 in the first row times the first number of the first column of the second matrix, negative 4, plus you'll take that second number in the first row of negative 2 times the second number of the first column, which would be 4, And that's it for your first number in the first row. To get the second number in the first row, you'll take the first number of the first row, which would be 6, times the first number of the second column, which would be -2, plus you'll take the second number of the first row, which would be -2, times the second number of the second column, which would be -6, and that's it for the second number in the first row. Now let's obtain the third number of the first row. You'll take, once again, the first number of the first row, which would be 6, times the first number of the third column, which would be 5, plus you'll take the second number of the first row, which would be -2, times the second number of the third column, which would be -1. It always goes row times column. Now to get the second set of numbers in the second row, we're going to work in the second row now. You're going to take the first number of the second row, which would be 1, times the first number of the first column, which would be -4, plus you'll take the second number of the second row, which would be 4, times the second number of the first column, which would be 4. That's it for that number. To get the second number in the second row, you'll take the first number in the second row of 1, times the first number of the second column, which would be -2, plus you'll take the second number in the second row, which would be 4, times the second number in the second column, which would be -6. That's it for that number. To get the third number in the second row, you would take the first number in the second row of 1, times the first number of the third column, which would be 5, plus you'll take that second number in the second row, which would be 4, times the second number in the third column, which would be -1. And then last but not least, why don't we go on to finding all the third row. So take the first number in the third row, which would be 0, times the first number in the first column, which would be -4, plus take the second number in the third row of 5, times the second number in the first row of 4. Now go ahead and take the first number in the first number of the third row, which would be 0, times the first number of the second column, which would be -2, plus you'll end up taking the second number of the second row, which would be 5, times the second number of the second column, which would be -6. Then you'll end up, for the final number, you'll take the first number of the third row, which would be 0, times the first number of the third column, which would be 5, plus you'll take the second number of the third row, which would be 5, times the second number of the third column, which would be -1. Now we can simplify this. Holy moly. This will turn into -24 minus 8. Then you would end up having -12 plus 12. You would then end up having 30 plus 2. Then you would have -4 plus 16, -2 minus 24, 5 minus 4, 0 plus 20, 0 minus 30, and then 0 minus 5. Yeah, that's a big one. You're going to end up getting the 3 by 3 matrix of -32, 0, 32. Then you'll end up getting 12, -26, 1, 20, -30, and -5. So there is your matrix A times B, the 3 by 3 matrix we said we were going to get. you get negative 32, 0, 32, 12, negative 26, 1, 20, negative 30, and negative 5. So there in fact is your AB matrix, a nice 3 by 3. Yes, you know what I'm going to ask next. It's going to be, can we do B times A? Can we in fact do B times A? Alright, so let's find out. B is what? It's a 2 by 3. A is a 3 by 2. Well, the number of columns in B matches the number of rows in A. So yes, we actually can do B times A. We can totally do B times A. Which means the dimensions of B times A should be a 2 by 2 matrix. So you see right away we're going to get a different matrix result. We're going to get a 2 by 2 this time instead of a 3 by 3. So let's take that matrix B, which would be all these numbers. I'm going to write them side by side so it's easier. All right. So what we do now is we're going to do the multiplication. So we should keep in mind get a 2 by 2 matrix, right? According to the rules of multiplication. So what you're going to do to get your numbers, the first number of the first row, you'll take the first number of the first row of B, which would be negative 4, times the first number of the first column, which would be 6, plus you'll take the second number of the first row, which would be negative 2, times the second number of the first column, which would be 1, plus you'll take the third number of the first row, which would be 5, times the third number of the first column, which would be 0. That's it for your first number. Your second number is going to end up being, you'll once again take the first number of the first row, which would be negative 4, times the first number of the second column, which would be negative 2, plus you'll take the second number of the first row, which would be negative 2, times the second number of the second column, which would be positive 4, plus you'll end up taking the third number of the first row, which would be 5, times the third number of the second column, which would be 5. Alright, so there are both entries for your first row. Let's go on to the second row. I probably don't need to make this box so big. Now to get the entries of your second row, you're going to take the first number of the second row, which would be 4, times the first number of the first column, which would be 6, plus you'll take the second number of your second row, which would be negative 6, times the second number of the first column, which would be 1, plus you'll take the third number of the second row, which would be negative 1, times the third number of the first column, which would be 0. Now let's move over to find the last number of the matrix, the second number of the second row. You'll end up taking the first number of the second row, 4, times the first number of the second column, negative 2, plus you'll take the second number of the second row, which would be negative 6, times the second number of the second column, which would be 4, plus you'll end up taking the third number of the second row, which would be negative 1, times the third number of the second column, which would be positive 5. And now we just got to simplify this. So this is going to turn into negative 4 times 6 is negative 24. Negative 2 times 1 is negative 2. So negative 24 minus 2 plus 5 times 0 is 0. Then we have negative 4 times negative 2. That's positive 8. negative 2 times 4, it's minus 8. So you have 8 minus 8 plus 5 times 5, which is 25. And then you have 4 times 6, which is 24, plus negative 6 times 1. So that'd be 24 minus 6 plus negative 1 times 0. That'd just be 0. And then you'll take 4 times negative 2. That'd be negative 8 plus negative 6 times 4. So negative 8 minus 24. And then you'll do negative 1 times 5. So negative 8 minus 24 minus 5 is going to give you, for the final result, the 2 by 2 matrix of negative 26, 25, then you'll end up getting 18, then you'll end up getting negative 37. So for A times B, you got a 3 by 3 matrix. For B times A, you got a 2 by 2 matrix with completely different numbers. You got negative 26, 25, 18, and negative 37. So there's that. Now I got two problems where we're going to solve for x and y again, but this time it involves matrix multiplication. So let's state the objective up here. Solve for x and y. This time there's only two of those problems, so it's not going to be so bad. So let's see. We are given the matrix negative 2, 1, 2 for the first row, 3, 2, 4 for the second row, 0, negative 2, 4 for the third row, times the matrix of 1, x, and 3, all set equal to 6, 19, and y. So let's establish something here. What are the dimensions of each of these matrices? 3 rows, 3 columns. This first matrix is 3 by 3, right? The second matrix is a 3 by 1. So yes, you could definitely do the multiplication since the number of columns in the first matrix matches the number of rows in the second. The result should be a 3 by 1. And according to this, the result here is a 3 by 1. So this checks out. We can totally do the multiplication. So let's go ahead and do said multiplication. So let's say we're going to multiply these two matrices here, right? The result should actually be a 3 by 1. So what you're going to do is you're going to take the first number of the first row, which would end up being negative 2, times the first number of the column, which would be 1, plus you'll end up taking the second number of the first row, which would be 1, times the second number of the column, which would be x, plus you'll end up taking the third number of the first row, which would be 2, times the third number of the column, which would be 3. And then we're going to get our second number, we'll take the first number of the second row, which would be 3, times the first number of the column, which would be 1, plus we'll take the second number of the second row, which would be 2, times the second number of the column, which would be x, plus we'll take the third number of the second row, which would be 4, times the third number of the column, which would be 3. And then last but not least, we'll take the first number of the third row, which should be 0, times the first number of the column, which would be 1, plus we'll take the second number of the third row, which would be -2, times the second number of the column, which would be x, plus we'll take the third number of the third row, which would be 4, times the third number of the column, which would be 3. And according to this matrix multiplication, all this should equal 6, 19, and y. Which means ultimately we're going to have two equal matrices. And I'll explain more about that in a minute. So you simplify this sum, you would end up getting, for your entries, you would end up getting x minus 2 plus 6 would be x plus 4. For the second entry, for your 3 by 1, you should end up getting 2x plus 3 plus 12, that'd be 14, 2x plus 14. And then you should end up getting, for your third entry, negative 2x plus 0 plus 12, well, that'd be negative 2x plus 12. All that should be equal to the right-hand side, which would be 6, 19, and y. Now we just need to solve for x and y. Well, let me look at you know what? It's 2x plus 15 for the second. Excuse me, I mismultiplied, misadded. It's 2x plus 15. I knew something wasn't making sense. Anyway, to solve for x, you could take your x plus 4, set it equal to 6, or take your 2x plus 15, set it equal to 19. It does not matter which one you choose. X will be the same for both of these. As for me, I'm going to vote we work with x plus 4 equals 6, right? That's going to be a lot easier. X plus 4 equals 6, that just gives you x has a value of 2. That's much easier to work with. Now, if you set 2x plus 15 equal to 19, you would also get that x equals 2. But we need to solve for y. Well, now that we know x equals 2, we can just plug that in. We can set y equal to this value here. So y is going to equal negative 2 times that x value of 2 plus 12, which would mean it would equal negative 4 plus 12, which would give y a value of 8. So in the end, x has a value of 2, y has a value of 8. And I got one more problem like this, then we'll be done with the lesson. All right, let's say here we have this one, 4, 1, 3, negative 2, x, and 1 times 9, negative 2, 2, 1, negative 1, and 4, all that is set equal to y, 15, negative 13, and 11. Another one where we got to solve the matrices for x and y. Well, again, this is an equality. This means the product of these two matrices will be identical to this matrix over here. So first thing, again, I can't emphasize this enough. Figure out the dimensions of your matrix. Matrices. Make sure these all check out. So your first matrix is 2 rows by 3 columns. So you have a 2 by 3 matrix. Your second matrix, you have 3 rows by 2 columns. You have a 3 by 2 matrix on the second one. So you can definitely multiply, since the number of columns in the first matrix matches the number of rows in the second. Which means your product should be a 2 by 2, and the end result on the right hand side, what do you know, is a 2 by 2. This all checks out. So we know the multiplication is good. Now we just need to actually do it, figure out what it is. So we're going to get a 2 by 2 matrix. So what you're going to want to do now, take the first number in the first row of the first matrix, multiply it by the first number of the first column of the second matrix. So take 4 times 9, plus take your second number of the first row times the second number of the first column. That'd be 1 times 2, plus take your third number in the first row, which is 3, times the third number in the first column, which would be -1. Now that's it for the first number of the first row. Now we're going to repeat this with the first row in the second column. So take the first number of the first row, 4, times the first number of the second column, -2, plus, go ahead, take the second number of the first row times the second number of the second column, 1, so you get 1 times 1, plus take the third number of the first row times the third number of the second column, which would give you 3 times 4. Now you're going to end up doing, to get your first number of the second row, you're going to take the second number, the first number of the second row, which would be -2, times the first number of the first column, which would be 9, plus you'll take the second number of the second row, which would be x, times the second number of the first column, which would be 2, plus you'll take the third number of the second row, which would be 1, times the third number of the first column, which would be -1. And then last but not least, to get your fourth number, the last number of the second row, you'll repeat the process with the second row, but this time the second column. So take the -2 times -2, plus take the second number of the second row, which would be x, times the second number of the second column, which would be 1, plus take the third number of the second row, which would be 1, times the third number of the second column, which would be 4. Which this is all going to simplify into, what we should get here is going to be 36 plus 2 minus 3 for the first number. For the second, you'll get -8 plus 1 plus 12. Then you would get, -18 plus 2x minus 1. Then you would get 4 plus x plus 4. All this should equal y 15, -13, and 11. So simplify this matrix on the left further. 36 plus 2 is 38, minus 3, that's 35. -8 plus 1 is -7 plus 12, that's +5. Did I write that down right? Oh, yep. I don't know where I got that 1 from. It's a 5. My bad. It's y5 -13, 11. Sometimes I see things when I'm transposing all this. I thought something didn't make sense. And then you would end up getting 2x minus 19 for the third number. Then you would end up getting x plus 8 for the fourth number. All right. All that should equal y 5, negative 13, and 11. Well, I think y is pretty self-explanatory. Y corresponds directly to 35. So you should end up getting a y value. You set y directly equal to 35. Well, there's your answer. Y equals 35. It doesn't get much easier than that. But we need to solve for x. You can either take 2x minus 19 equals negative 13, solve for x that way, or just take x plus 8 equals 11 and solve for x that way. It won't matter. Your answer for x will be the same. As for me, I'm going to opt for x plus 8 equals 11. I think most people would. So x plus 8 equals 11, which means x equals 3. And what do you know? If you plug in the x and y values, you would get two identical matrices. So that's it for matrix multiplication. I know this lesson was a lot. Matrix multiplication is very different from what we've done. The next lesson should be a little bit easier. We're going to introduce matrices in the sense of using them to solve systems of equations. We will talk about augmented matrices, the identity matrix, and row echelon form. And then the lesson after that, we'll talk about reduced row echelon form. So I hope everyone has a great day. Take care.